Hey there, Attic PC Guy here, and welcome to the first in a series of videos that I'm going to be making about heat. Now, I've been doing a few videos about overclocking lately, and one thing I keep mentioning is that you have to keep your cooling able to cope with the increased heat from overclocking, and you have to keep your temperatures under control in your components. Now, why is this exactly? Why do computers need to be kept cool? Why do we have to keep an eye on temperatures when doing more intensive work? And why is that so important? Now, the first thing that we need to keep in mind, and it's the general accepted idea that there are two things that can kill your computer or damage it over time and degrade it over time, and those are heat and voltage. Now, voltage I have mentioned before. Voltage can just basically fry your electrical components, your circuits on your transistors on your CPU, GPU, whatever. And then there's heat, and I've mentioned it several times, but I never really gave a clear explanation why and why that is so important. Now, there are two things that you can happen when your computer runs too hot, any part at all. Now, there's the danger that it is so hot that it'll just basically melt down the parts, not necessarily the parts themselves, but there are low temperature solders that are basically used to solder together components or parts of components, and those can just melt away if the temperature gets too hot. And by too hot, I mean above the 100 and something degrees, which your computer should never really reach. Then there is also something else, which is, as you might know, most materials, but specifically metal, contracts and expands with temperature differences. So bringing the temperature over a certain range, it will make your metallic parts in your components to just expand, contract when the computer is cooled down, expand, contract, and that will lead to just plain physical mechanical wear on the part from that repeated expansion and contraction. So that will in the long term also affect or even damage the operating of your component, be it a GPU, CPU, RAM, whatever. It's all vulnerable to that effect if kept running too hot. Now, what is too hot exactly? Now, that varies per component. That varies. The CPUs can usually be safely running for short amounts of time near the 100 degree mark Celsius. It's usually safer to not let them go above the 80 degree under load if it's a more prolonged load. And by prolonged load, I mean more than a few minutes. If they're at 100 and something for a few minutes, it's not horrible, but it's not really ideal either. But I would not have that as a constant temperature for my CPU, so I would keep the 80 degree under load, and I mean realistic loads like gaming, productivity such as video editing and rendering. That is what I call realistic loads, not benchmarks, because those are putting an extra load on your PC that is not really occurring on natural situations. And for your GPU, I would advise around the same 80-ish temperature at the very most. Now, there are also other temperatures like RAM, hard drives, SSDs that you have to keep in mind, but those usually are not really a problem unless you try very, very hard to overclock your RAM. And as for the hard drives and SSDs, etc., they are just normally cooled by the normal regular airflow that you have in your case anyway to cool the other components. So that is something that you normally do not really have to worry about. It's generally revolves more around the CPU, the GPU, and to a lesser extent the RAM. And that's mostly when overclocking, because when not overclocking, the coolers that come with the parts usually are sufficient unless it's a very high-end CPU that I would still recommend an improved aftermarket cooler as opposed to the one that might come included in your package. Now, how do these parts even generate heat to begin with? It comes down again to the electricity. Every part in your computer requires electricity to function, and when electricity is basically sent to that part through the power delivery system, it will increase the temperature of that part. The more intensive workload you are doing on that part, the more power it will require, and thus the warmer it will become. Now, some parts might have some limits. Your CPU might actually shut down completely if it gets too warm. Other parts might not. but in the most part there are some safeguards that if it gets too hot, it will simply shut down and stop you from damaging it via the increased temperature. Okay, so that's a theory of temperatures, well, how it works and why is it a problem and why you should keep them in check. But what can you do about it then? The solution is usually simple. You get better cooling for your components. If you cannot get better cooling, you have to decrease the load that you are putting on your parts. But that's counterproductive because, I mean, you're basically crippling yourself by not using your PC to your full potential. So as long as it's possible, as long as you can, and as you can, I mean, your case might not have more spots for you to put fans on, uh, that kind of thing. But you can still upgrade to a better fan. If a better fan or a better cooler is not sufficient, maybe it's time to change for a case that supports more cooling or better cooling. But in any case, if you are running into CPU temperatures that are too high, you might want to invest in a better cooling for your CPU. If you already have a very good cooler for your CPU and it's still not enough, water cooling is an option. I will make some videos about it as well. Um, Water cooling is an option. There's AIOs. You can do your custom loop. AIOs are a lot simpler. It's just install and forget. It's not any different than putting on a fan. Um, if your GPU is getting too hot, the only option is water cooling or improving the airflow in your case in general, which is also an option. And if you just need more airflow in your case in general, then you can get fans with higher RPMs. That means that they'll spin faster, also produce more noise. But more than the RPM itself, you should be looking at on the fan specifications for CPM, which is sorry, CFM, which is cubic feet per minute, which is a measure of the amount of air that that fan can move per minute while it's spinning at a certain rotation speed. Now, what you have to keep in mind, bigger fans move more air, and usually if they move more air, they don't have to spin as fast to move the same amount of air, which means that they will be silent, a bit more silent, because they won't move as fast. So if possible, I would always go for bigger fans because it will probably make your computer more silent while keeping it cooler as well at the same time. So it's a bit of a two birds, one stone kind of thing. Now, for your CPU, yeah, I already said that. For your CPU, you can always put a stock aftermarket cooler. Yeah, it's basically a cooler that you purchase separately from your CPU, and they usually perform a lot better than the ones that come included, because the ones that come included usually manufacturers are already expecting you to, if you need a better one, to just get a better one, and they don't really put a very good cooler on there. It's just sufficient for the basic operations. Now, okay, so you can improve the cooling on your system by either water cooling or putting better air coolers, or just improving the general airflow on your case, which is also something that should be mentioned. If you have a really cluttered case with cables going everywhere, that's going to obstruct the airflow a bit. So you should try to keep your cables a bit managed. There's I have not really looked into reviews and not reviews, but testing and benchmarks. There's people that say that it doesn't matter all that much, but in any case, it matters some. And if you're running into problems, just that little tiny sum that of influence that the cables might help improve your situation and might make your situation at least bearable. So it's worth keeping that in mind and trying to keep a clean case with the cables not going everywhere. Something also to keep in mind is that there will be dust buildup in your system from the air constantly going. If you have filters on your fans, it will improve the dust situation, but it will also limit the airflow because the air will have to struggle and fight to get through that filter. So you have to keep that in mind and strike a balance between having a clean case and having a bigger amount of airflow. In any case, you should clean out your dust. In any case, har 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 puns. Anyway, you should clean out your dust in your case every once in a while when it's getting too bad. Not forgetting the dust on the fans themselves and on the filters to keep the filters clean as well if that's possible. But that's something that for most people that have some experience, they probably do it already. Other point to consider, thermal paste. mostly on your CPU, not on your GPU unless you're running water cooling, but on your CPU, between the cooler and the CPU itself, there's a small film of thermal compound. That thermal compound is there to help facilitate the heat exchange between the CPU and the cooler. Why is that necessary? Because as much as the factories and manufacturers try, there is always a manufacturing tolerance that they try to put to have the bottom of the plate from the cooler and the top of the CPU. They try to have it flat, of course, but there is always manufacturing tolerances that it's not completely 100% flat on a microscopic scale. Now, what does that mean? It means that there is not full perfect contact between the two, and the thermal conductivity of those plates is a lot better than air. So if there's air pockets between the two, it means that the heat won't be conducted as good as it should between the two plates for it to be removed from your system by the fans and the exhausting system. So why is the paste there? The paste is a very thermal conductive substance that is, it's a paste. It's not completely solid, it's a bit fluidy, and it's there to basically fill any possible tiny little microscopic gaps that there might be between the two plates. Why does it have to be changed? Because over time with the heat, and again the heat contracting, expanding the paste as well, it happens to every material, the paste will end up being, slightly cured and cooked. And while a bit of curing actually helps, if you leave it there for an extended period amount of time without replacing it, it won't work as great. It will start losing its properties. So you will want to replace that paste anywhere between the 6 months to a year, at the very most, that is. But every 6 months to 8 months to a year, you would want to take off the fan, wipe the paste away. You can do it with a little bit of 96% alcohol fluid. Um, Wipe it away completely, clean it, apply new paste. There's various methods. I might make a video on it later, but anyway, you apply the paste, you put the cooling back, and it should help a bit with managing the temperatures. Now, how do you even keep track of the temperatures, you might ask? Now, there's the obvious. If your fan is spinning like crazy because the CPU is getting warmer or the GPU is getting warmer, um, then that's a pretty good sign. If you put your hand near the exhaust, not in the exhaust obviously, don't want to lose a finger, uh, but if you put your hand near the air exhaust and if it feels super warm, like warmer than it should, warmer than it used to in the past, that's a pretty good indicator that your PC probably needs a bit of maintenance in there. But other than that, how do you check if under normal operation your PC is running, let's say, hotter than it should? How do you know exactly the temperature that it's running? Well, there are monitoring. Some motherboards and some PCs that come with stuff pre-installed might already have monitoring software in there that will let you keep an eye on it. Others might not, especially if you have built it yourself and installed the system yourself. You might have to get your own monitoring software. Now, there are many options out there. There's HW, Info64, there's SpeedFan. I never liked it much, but it's out there. And the one I personally use is HW Monitor. It's a free program. It has a pro version, but it's not really necessary if you ask me. The free version is more than enough. And it gives you a lot of information on every component on your system. But for this video, the most important would definitely be the temperature. Now, the temperatures on HW monitor, you have, depending on your motherboard, you'll have sensors here, sensors there, but what you mostly want to see is the core temperatures. Now this will vary a lot and you will see them jumping up and down because depending on how much work every core is doing, they'll get more or less temperature. But you will see that, for example, now on my PC at near idle, it's not completely idle, I have programs open, I have the recording software open, for example, but as you can see, my PC is also with a bit of an overclock. It is sitting at around 30 something degrees Celsius on idle, and yeah, that is pretty reasonable. It's you just have to keep an eye really. if it's not getting too hot, mostly under load, because idle temperatures, as long as not they're stupidly high, like if your PC is at 50 degrees, well, no, it's not doing anything. And I don't mean like the 40, I just had a 53 spike right there. It's literally just a spike. When a CPU gets instructions, processes them, it spikes in temperature, but then it's removed immediately. So it's literally just a spike. What you want to see is where it's sitting at mostly, and it's mostly on the mid 30s, low 30s right now, and that's even with recording. Now, if it's sitting on mostly on average at the 50 degree, 60 degree when idle, then there is something clearly wrong with your cooling solution and with your PC. Right now it's spiking because some program in the background is doing something. As you can see, it varies a lot. But if you come here and the processor load is low, it's not really low right now in my case, but if the processor load is low and your temperatures are high, there is something wrong with your cooling and you need to take action to solve that. But otherwise, idle temperatures are not super important. Now, when your processor is under load, like mine right now is under average load, I would say, but if when it's under high load, uh, like 80% plus on all cores or something. And if it's spiking, if the temperature is spiking to 80 plus 90 degrees, then you have something to worry about, and then you should definitely consider investing in better cooling. Now, this has been the first in a series of videos that I'll be doing about heat. I will definitely be doing a few more series. I'm planning a video on basically how cooling works, how do coolers remove the heat from your system, a bit more on the technical process that it works, as well as a bit of an introduction to water cooling. I'm not a water cooling expert, I'm gonna say it myself. I have never really done a custom loop, but I am planning to, and I like that. I like to research on stuff, even if it's not stuff that I have or use. So I will also do a video on that aspect because I have been mentioning heat and temperatures a lot on my past few videos, and as well as overclocking. And cooling is an essential part of that part of PC building, of being a PC enthusiast. Temperatures are always in your mind, and if you're going to want to learn more about that, you have to learn more about temperatures. So I'll be doing a video on that, a few videos on that even, shortly, and I'll let you guys know. For now, this is an introduction of why is heat important, how it works, when you should worry about on a basic on a very surface level what you could do to help if you're running into heat issues, and I'll go more in depth next time. This has been Ethic PC Guy, and I'll see you next time. Have fun.